In video 2A, part 2, we're going to be finding the slope of a line when given the equation, and we're going to write some equations for parallel and perpendicular lines. So remember in the last section, one of the last sections, we talked about how when lines are in the form y equals mx plus b, the m, the number in front of the x, indicates the slope of the line, and the b indicates where it hits the y-axis, and we call that the y-intercept. And so on my graphing calculator over here, I'll go show you a couple lines here. So if I entered y equals and I had 2x plus 5, what that means is my line has a slope of 2. When it has a slope of 2, it's going to be going up 2 and over 1, because as a fraction, when my slope is equal to 2, that means 2 over 1, which is a rise of 2 and a run of 1. So my line is going to be going uphill fairly steeply because it's going to rise more than it runs, and it's going to hit the y-axis at 5. So when I hit graph, you'll notice that it does exactly what I just said. It hit the y-axis right here at 5, and it's going up 2 over 1, up 2 over 1 for the slope. Now when I go back to the y equals and I start messing with both the slope and the y-intercept, if I made that a negative 1/5 x, what will that do to the line? Well, I've just changed the slope from positive to negative. So the line is going to go downhill now. It's going to go down 1, because when m equals 1/5, it means it's going to go down 1 and it's going to run 5. So it's going to be very gradually going downhill. Where will it hit the y-axis? Depends on where I tell it to. If I don't hit anything right now, it's going to hit at 0. Watch, because there's nothing, it's blinking there waiting for me to enter the y-intercept. If I don't enter anything, it means it's 0. So you're going to see a very gradual downhill line slicing through the origin, because remember we're looking for that y-intercept. So one more. Now let's suppose I did the line 2x minus 3. What's that going to be like compared to the other two? Its slope is the same as the first one. It's got a slope of 2. So when lines have the same slopes, they run parallel to each other. However, this one's going to hit up at 5 and this one's going to hit down at 3, and I'll go graph that. So line number 3 in black there is doing exactly what I said it's going to do. It's running parallel to the first one, which was in blue, and it's hitting down here at negative 3. So this form that I'm entering these lines in under the y equals to graph them is called the slope-intercept form of the line. And when a line is in slope-intercept form, so back to the notes over here, let's call it y equals 7x minus 1, and they ask you for the slope, you just pluck off what's in front of the x. Bing, bang, boom. Slope is 7. What does that mean about the line? It's going to be super steep. It's going to be going uphill because that slope is positive. And it's going to hit the y-axis at negative 1. And there it is, coming through, super steep, hitting the y-axis down here at negative 1, and the slope is 7. For part B, example B, I mean, let's suppose I had y equaled, now let's take it out, let's shake it up a little bit here. For part B, what if it was 2x plus 3y equals 5? You'll notice that I cannot now say that the slope is 2. The slope is what's in front of the x once it is solved for y. So I have to get it in a form where I can enter on my graphing calculator here. What's y? I need to enter the slope for the calculator and the y-intercept. So I need to isolate this or solve it for y. Doesn't like when I shift from the calculator. All right, so I need to subtract 2x from both sides. I'm going to try to get y all by itself. And I get 3y is equal to 5 minus 2x. I can't go enter that. Notice this doesn't say to enter 3y. It says to enter y. So I have to divide every single term through by 3. And I get y is equal to 5/3 minus 2/3 x. And the slope is what's in front of the x. So my slope for this line is negative 2/3. It's going to be going downhill. It's going to be falling 2 and running 3. So it'll be sort of gradually going downhill. I could confirm it on my calculator, but you just trust me. So when it asks you for the slope of the line, you need to solve for y, and then it's whatever in front of the x. So for an example C that you can put in your notes, last one, what if you had negative y minus 7x equals 4? I don't know what the slope is. I need to solve it for y first. So I'm going to move the 7x over. I'm going to get a negative y is equal to 4 plus 7x. It does not say to enter negative y. It says to enter y. So I need to divide everything through by that little invisible 1. Basically take the opposite signs of all of these, and I'll get y is equal to negative 4 minus 7x. What's the slope of this line? Negative 7. It's what's in front of the x. If I really technically put it in slope-intercept form, it'd be negative 7x first minus 4. These are equivalent expressions. So let's go enter that on the calculator to see what it gives us when I graph it. You should at this point be able to predict what that's going to graph. The minute I hit a negative 7, I'm telling the calculator to drop 7 and run 1, and so it's going to go very steeply downhill. And then the minute I hit a minus 4, I'm telling the calculator to hit the y-axis at negative 4. And there it goes. Second task. This one's a little bit more difficult, so I'm going to do one example, but I'm going to change this to a part A parallel to, and then for part B, we're also going to do perpendicular to that line. And one example, because I'm going to go really slow, but if you are stuck on this, you're just going to have to watch the example again. So I want an equation that's going to go through 2, negative 1. I'm going to go over to my graph here. I've got a point sitting here at 2, negative 1. And I want it to run parallel to this line. So I'm going to go enter that line on my graphing calculator just so you can get a visual of what we're being asked to find here. I've got some line, negative 2/5. You should be able to predict what that means. I'm going to have a downhill line. It's going to be dropping 2 and running 5. And so it's going to be gradual downhill. The minute that I tell it to have that slope, it's now blinking, waiting for the y-intercept, which is plus 3. So I just go enter that equation in, I hit graph, and up pops the line. Y equals negative 2/5, gradually downhill line. It's hitting the y-axis at 3, and my task is to find the equation for the line parallel to it that goes through the point 2, negative 1. So really what I'm looking for, if I were to draw it, I'm looking for the, let's make that dot by the equation of this line. Well, what do I know about that line? First of all, to run parallel, I know what its slope has to be. It has to be the exact same thing as this. So I'm going to write that down. When I enter y equals mx plus b on the calculator to try to get my calculator to graph that red line. I drew it, but how could I get my calculator to graph it? Well, I'm going to steal the slope of the one above it because I need to run parallel, so I need to have the same slope. But I also have to make sure, so let's go back over here. I'm going to steal this slope because I'm running parallel, so I'm stealing you. Y will have to equal negative 2/5 x plus. My question is, what do I enter here to force it, the line, to go through this point? I'm going to put plus b. What is that? Well, what I'm going to do is, I know I need to go through the point 2, negative 1. 2 is an x coordinate on the line. Negative 1 is a y coordinate on the line. What I know about my line is the y values. negative 1, right here, have to be equal to negative 2/5. Again, I stole the negative 2/5 from this one because I need to run parallel to it. So I need to have the same slope times x, which is 2, plus b. I'm going to go solve this for b because it's blinking, it's waiting. What's b? And I'm going to go figure it out. How do I do that? I just do the arithmetic here. I do negative 1 is equal to negative 4/5 plus b. Again, I'm looking for that y-intercept. My calculator's being very patient, blinking over there, waiting for me to enter the y-intercept. I'm going to add 4/5 to both sides. Negative 1 plus 4/5. If it was negative 1 plus 5/5, it'd be negative 1 plus 1, which is 0. But this is negative 1 plus 4/5, so I'm still going to be a negative. I'm going to have a negative 1/5 is equal to b. Now I've got it. I know that my equation I'm going to enter is going to have the same slope of 2/5. So 2/5, it was negative, x. And I just figured out that the y-intercept will have to be a negative 1/5. Let's go see if it jives over here. So it's blinking. It's been very patient. I figured out that I need to enter a minus 1/5 right there. I'm going to go hit graph and see if it does what it's supposed to do. Is it running parallel to the blue line? Indeed it is. Why is it? Because I gave it the same slope. I made both of them have a slope of negative 2/5. Is it going through the point 2 over and 1 down? It is. So it meets both criteria. So we're going to repeat the process again just so you get how this is working. I'm going to go clear off the second line, but I'm going to keep the first one there because, and move that over just a tiny little bit. I'm going to change it to one word change here. Instead of running parallel, I'm now going to run perpendicular. All right, so here's the difference. Here's my format for my line, y equals mx plus b. Again, look at my calculator. It's blinking over here. It's waiting for me to enter the slope. When I ran parallel, I stole the slope because parallel lines have the same slope. But when you run perpendicular, you can't just steal the slope. You want to make sure they hit at right angles. And to do that, we do the opposite. So instead of negative, it'll be positive. Reciprocal, which would be 5/2. So you take the opposite and you flip it over. And that'll cause the line to run perpendicular. The minute I go like this, I will have a perpendicular line to the one above it. However, I also have to make sure I send my line through this point because, okay, I have a line sitting there and I need to run perpendicular. Which one do I pick? This one, this one, this one, this one? Well, this is telling me you have to go through a specific point. So I'm going to force my line to do that. I'm going to go like this, and I'm going to go figure this out. So here's the process again. If you're running parallel, you steal the slope and plug the point in and solve for b. If you're running perpendicular, you do the negative reciprocal of the slope, plug the point in, y is negative 1, when x is 2, and then I solve for b. Because again, my calculator's blinking here. It's waiting. What's b? Where are you going to send me? If I don't enter anything, it's going to send me through 0, 0. I'm going to force it to go through the point 2, negative 1. I'll get negative 1 is equal to 5, because these twos cancel, or you could say it's 10/2, plus b. I'm going to subtract the 5, and my y-intercept that I need to enter for this will be negative 6. Let's see if it works. Minus 6. Oopsie. Minus 6. So if I did this correctly, my two lines when I hit graph should be perpendicular, and my second line should go through the point 2, negative 1. Let's go take a peek. There's the first line that they gave me, negative 2/5 x plus 3. Here's my second line coming in, hitting at a right angle. It doesn't quite look exactly like a right angle, but that's because your calculator is longer than it is tall, so it gets a little bit stretched out. Did it go through the point to -1 again, though? See, it did, so it's all good. So that's the end of this video. And your task is to do worksheet 2.2 B and C, but note you only have to do every other odd. So you're going to do 1, not 3, then 5, not 7, then 9, etc. on both sheets. I don't need you to do a bunch of these. I just need you to do some of them really well. Have a good one.